Okay, let's talk about isomers. Isomers are compounds with the same molecular formula, but different structural formulas, and therefore different names. Okay, so let's look at these two examples that we have right here. We have same molecular formula. So that means 1, 2, 3. So C3, 1, 2, 3, C3. H, 1, 2, 3, 4, 5, 6, 7, 8. Ooh, 7. 1, 2, 3, 4, 5, 6, 7. H, 7. And then what's left is BR. And even though this is terrible writing, and a BR. But do you see this? 1 bromopropane, 2 bromopropane. So the address is different. That means a different name. If you have a house at 112 and a house at 114, they're not the same house because they have different addresses. So if the name has a different address, it is different, a different structural formula. Okay, so again, isomers have the same molecular formula, but a different structural formula and therefore different properties. Isomers, same molecular formula. Count them up. It's C5, H10. Doesn't matter which one you're looking at right here, but they have different names because they have different addresses. Okay. Also, this one right here, I haven't really talked about this a lot, but this is called a cyclo. So I would say this is cyclo 1, 2, 3, 4, 5 pentane. Cyclopentane. Okay, just so that you're familiar with it. But anyway, the purpose of showing it here is that isomers have the same molecular formula. Count up the atoms, it's identical, but they have a different name because they have a different structure. And because they have a different structure, they have different properties. Okay, so let's look again. Isomers. They have different properties because of their different structures. Butane, for example, you can see right here, has a gasoline-like odor. It's what's used in lighters, and its boiling point is 274 Kelvin. But 2-methylpropane, which you can see pictured here, is odorless, and its boiling point is 262 Kelvin. Different structures, different properties. Now, these two are not isomers, even though they might look it. Okay, so 1, 2, 3, 4, 5, they're both C5, 3, 5, 7, 8, 10, and they're so C5, H10, same molecular formula. But why aren't they isomers? Well, we have to put an address for the bond, right? So we can number this 1, 2, or going this way, 1, 2, 3, 4, 5. So it would be 1 pentene. And so look at this one. Look at where the double bond is. It could be 1, 2, 3, this would be 4, 5, or 1, 2. So this would also be 1 pentane. So even though on this side, the double bond's over here, and in this one, it's over here, same name. If it has the same name, they are not isomers. It's just like looking in a mirror. So when I look at the mirror image, I go, oh my gosh, that is not a different person. No, it is me, just in the mirror. So these two are mirror images. So they are not isomers. Again, these are not isomers. Why would they not be isomers? They have a different name, right? Because I see a double bond in one and not in the other. So why are they not isomers? They do not have the same formula. So they have to have the same molecular formula and then a different name. Okay? So do the compounds have the same molecular formula? You have to say yes or no. If it's no, they're not isomers, period, end of story. If they do have the same molecular formula, do they have the same name? So you have to look, do they have the same name? Yes or no? If yes, the compounds are not isomers because they literally are the same thing. It's just like looking in a mirror turned another way. If they don't have the same name in that case, then they are isomers. So two key properties. Isomers need the same molecular formula, different structure, and that different structure comes from having a different name. Okay, an easy way to draw an isomer is just to change the address. So here's an example right here. You can see this would be 1-chlorobutane. Easiest way to make an isomer, just move that Cl. So move it here. Now the address is 2, so it would be 2-chlorobutane. Same molecular formula, different structure. How do we know it's a different structure? It has a different name. Okay, another easy way to draw an isomer is to take one carbon off the chain and make it a branch. So what do I mean? So you can see this is hexane, okay? So what I'm going to do is remove a carbon from the chain. So I'm going to take a carbon off the chain and I'm going to make it be a branch, okay? Now, if I put it right here, all I do is just put it right back on the same one. So I don't want to do that. So I need to put it into a middle carbon, okay? So when I do that, right here, you can see all I did is take this carbon and put it right here. Now I have a new name, 2-methylpentane. New name, new structure, same molecular formula, isomers. All right, so for this one, for example, to draw an isomer, take this and put it here, right? So it would be, let's just draw a quick sketch, see, without all the H's. So I would have now a chain of 4 with a branch like this. And then I would add all the lines for H's. Easiest way, make it a branch. The next easiest way is to change the address. So do you see this functional group? This would be 1-butanol. So the easiest thing to do is to give it a new address. So instead of putting it on 1, let's put it on 2. So this would be 2-butanol instead of 1-butanol. New name, new structure, same molecular formula, isomers. And there you have it. That's isomers. Easy peasy, lemon squeezy, right? I hope you learned something new today.